So welcome to another video. In this video, I've taken electrolysis questions. These electrolysis questions have been taken from IGCSE papers 2025 boards. All of these are board questions. So these are the kind of questions. This is the PDF that I had made. And the good thing about this lecture is that comprehensive treatment has been given to electrolysis. These are the topics which I have covered during this about an hour long video. So there are two electroplating questions: copper sulfate electrolysis using inert as well as active electrodes. And I've taken and explained the comparison between concentrated dilute and molten NaCl because the treatment is different. Electrolysis of concentrated copper chloride, dilute sulfuric acid, molten potassium chloride, hydrogen oxygen fuel cells. So this is a pretty comprehensive treatment of the electrolysis portion. And see, I've put the basics of electrolysis in the end. The timestamps are available. If you just want to do the question papers, previous year question papers, you can start from the beginning. But if you want to revise the concepts also, then as per the timestamp, just have a look at, I think, about 7 to 8 minutes of basics of electrolysis, and then you can start the PYQs. So I hope this lecture is useful for you. Let's start. At the first question, electroplating of a steel object. Now, the student makes three statements. The steel object turns a reddish brown color, aqueous copper sulfate changes to paler blue color, copper electrode becomes thinner. So let's try to understand. We have a power supply. This is our anode. This is our cathode. We understand that at anode, oxidation will take place here. Red cat reduction will take place at the cathode. So these are the things that we understand. We also understand that the negative charge will follow the clockwise direction. So the negative charge should flow something like this. This is the direction. This is the direction in which the negative charge should flow. Now this is the steel object. The cathode is made the steel object. The copper electrode. We are electroplating the steel object. So basically what we want is that the copper should move from this side to this side, because we are electroplating the steel object. So this should get a layer of copper over it. This is how it should look like. Now there is the electrolyte is aqueous copper sulfate. So when they say aqueous copper sulfate, what you need to remember is that we will have the ions that will have a Cu2 positive, SO4 negative, will have H positive, and will have OH negative. See, because it is aqueous, we will have the ions of H positive and OH negative also. They come from H2O, and we will have Cu2 positive and SO4 negative that come from copper sulfate. So basically, in the container below, we'll have four kind of ions. There'll be two positive cations and there'll be two positive ions. Now there'll be a competition between, say, Cu2 positive and H positive. There'll be a competition between Cu2 positive and H positive. Just try to visualize that they will rush towards the negative side. They will rush towards the negative side to get discharged. And there'll be a competition between SO4 negative and there'll be a competition between OH negative. These are anions. They will rush towards the positive electrode. So there'll be a competition between sulfate 2 negative and OH negative. But there is one important thing that you need to understand. The important thing that you need to understand is, this is what we were discussing previously also, that there is a selective discharge of ions. Of course, there is a factor of relative position in electrochemical series, so which ions get discharged. But then there is something called nature of electrodes also. Depends upon the nature of electrodes also. If you look closely, what we have here is a condition where the electrode, this electrode itself is copper. When copper is there, then almost the whole of the process is overtaken by the electrode itself. The whole of the discharge is basically ruled now by the electrode. So as to say that though there was a competition, on the anode side, at the anode side there was a competition between sulfate 2 negative and hydroxide negative, which will get discharged. But what will happen here is that because the electrode itself is copper, so copper gets discharged. Okay? So as to say that the whole of the process is hijacked by the electrode. If the electrode is an active electrode, then whole of the discharging of ions the process of discharging of ions gets hijacked by the electrode itself. So everything is decided by the electrode. So in this case, the copper says, boss, you guys won't get discharged. I am getting discharged. So Cu becomes Cu2 positive and 2 electrons plus 2 electrons. So oxidation is taking place. Oxidation is loss of electrons. So this is what happens. So Cu2 positive enters here. You will see Cu2 positive here. And these 2 electrons, just to visualize, you can imagine these 2 electrons going up like this. So Cu2 positive will enter the electrolyte and 2 electrons will rise up. Just to visualize, you can visualize it like this. Then the Cu2 positive, they will rush towards the negative terminal at the cathode. And at the cathode, when there is a competition between Cu2 positive and H positive, so here again, see, the simple thing that you need to understand is once you have an active electrode, the active electrode hijacks the process. So Cu2 positive will be taking care of it. It will be playing the major role at the cathode also. It will be playing the major role at the cathode also. This is another way you can visualize. So in the on the cathode side, there will be a reduction. Reduction is RIG. Reduction is gain of electron. So gain of electron implies that Cu2 positive will take 2 electrons. Just to visualize again, imagine 2 electrons are coming from above. The Cu2 positive will eat these 2 electrons and become Cu, and the Cu will get deposited here. So just try to visualize that on the left side what is happening is, on the left side the Cu2 positive, the Cu is entering the electrolyte as Cu2 positive, and on the right side of the paper that you are attempting, on the right side of the paper, what will happen is that Cu2 positive, which has entered the electrolyte, will start getting discharged as Cu and will start forming a layer upon the steel object. And of course, that is what we want. That is what electroplating is. So now let's start looking at the choices. Now, another thing that you remember is that we have copper sulfate. Yeah. So with Cu2 positive, we have aqueous copper sulfate solution in our container. The concentration of Cu2 positive will always remain the same. Yeah, because Cu2 positive, the concentration remains the same because this part is supplying Cu2 positive ions. So concentration here will remain same. So steel object turns a reddish brown color. Of course, this happens because a layer of Cu2 positive is deposited on the steel. Aqueous copper sulfate changes to paler blue color. It doesn't happen because Cu2 positive is getting, we are getting the sort of, you can almost say, infinite supply of copper to cations from the anode. So it doesn't change to paler blue color. Copper electrode becomes thinner. Of course, it becomes thinner because it is giving Cu2 positive ions. So choice 1 and 3 is perfect. So our answer would be C. Now, question is about electroplating. Let's look at the question. The diagram shows an experiment to electroplate a nickel spoon with silver. Now, before I start this question, in electroplating there are few things that we need to understand. The first thing that we need to understand is that whatever we want, the material that has to be electroplated. So for example, in this case, nickel spoon is being electroplated. So nickel spoon should be the cathode. It should be the right side. It should be the negative terminal. So whatever you want to be electroplated, you want a spoon to be electroplated, you want a tray to be cup tray, glass tray to be electroplated, you want a bike rim to be electroplated. So any any product that needs to be electroplated should be the right side, the negative electrode, the cathode. So always remember that. This is the first thing that we need to remember, because in electroplating these kind of questions can also be asked. The second thing that we need to understand is that the material that you want to electroplate with. So for example, I want to electroplate a plastic spoon with the gold. Let us say, or I want to, for example, in this case, I want to electroplate nickel spoon with silver. So this the material that you want to layer upon should be the anode, should be the should be the left terminal, should be the anode, should be the positive electrode. Always remember that. The other thing that you need to understand is that the electrolyte should be a sort of the material with which you want to electroplate with. So for example, if I want to electroplate with silver, spoon with silver, then there should be a salt of silver which should be there in the electrolyte. So these are the few things that you should remember whenever you are doing electroplating questions, because these are common questions that can be asked. So now let us look at the question again. So electroplate a nickel spoon. So this is a spoon that has to be electroplated. So this will be the cathode with silver. So this would be silver and this would be the anode. There would be a salt of silver which will be the electrolyte. So for example, in this case, though it is not mentioned, just to give you an example, I have taken the example of silver nitrate. So this is how the things are done. Now, what we always understand is that at anode, oxidation will be taking place. At cathode, reduction would be taking place. Reduction is gain of electrons. So here gain of electron will be taking place. Oxidation is loss of electrons. Oxidation is loss of electrons. Here loss of electrons will be taking place. So we will have on the anode side, what will be happening is, because it's an active electrode. So active electrode. So the electrolysis will be based on the active electrode only. So on the anode side, on the positive terminal side, you will have silver, which will be which will get transformed to Ag2 plus and 2 electrons. So one way of looking at this is that 2 electrons will be pushed up and Ag2 ions will be entering the electrolyte. So Ag2 positive will be entering the electrolyte. And on the right side, what will be happening is that you have Ag2 cations, which are in the which are part of the electrolyte. They will be accepting 2 electrons, which you can visualize as if they are coming up from up to down. They will be eating up these the Ag2 positive cations which are there in the electrol. They will be eating up these 2 electrons and they will be forming silver. So now if we look at the the movement of ions also, if you see that the electrons they are moving in this direction. They are moving in this direction. So electrons are moving up here, and here the electrons are moving down. This is the flow of the negative charge. And if you look closely at the flow of the positive charge, the Ag2 positive had entered here. Then it went like this. So this is the flow of the positive charge. So what I've tried to do in this question is try to give you a brief of the electroplating. The movement of the movement of cations and anions is also a question which can be asked. And we have also understood that if there is an active electrode, what happens? Because if the active electrode is there, then rest of all the things are taken care by the active electrode only. So the answer for this question, which row correctly describes the positive? Let me read the question. So which row describes the positive electrode, the negative electrode, and the electrolyte? So the positive electrode is pure silver, as we have discussed. The negative electrode would be nickel spoon, and the electrolyte would be silver nitrate solution. It would be silver nitrate solution. Remember that whatever material that needs to be electroplated, so don't take you can't take nickel nitrate because you have to electroplate silver. Silver nitrate solution has to be taken. This nickel spoon, this can be some other material also. But if you want to electroplate, say for example gold, then gold will be on the left side. It will be the positive electrode. So let's look at the next question. Pretty interesting question. So electrolysis of copper sulfate is carried out using the apparatus electrodes are made up of platinum. Now this becomes an interesting question because first what they have done is in this question they have taken aqueous copper sulfate and they have taken electrodes made of platinum. There are few questions they have asked if the electrodes are made of platinum, what happens? And then in the second part, what they have done is that the electrodes is done using copper electrodes. So then they have asked few questions regarding that. So it becomes pretty interesting. So you should have full awareness, full understanding of the process. Only then you will be able to do the full question. And you can compare this electrolysis of aqueous copper sulfate using inert electrodes. So in this question, they have done aqueous copper sulfate using inert electrodes and active electrodes. Previously, we had done the electrolysis of copper chloride using concentrated aqueous, using concentrated solution and inert electrodes. So you can have a look at this question again because it's a good comparison. So now let's start looking at this part. See, it's a aqueous solution. It's a copper to sulfate solution. They haven't mentioned the concentration, so this would be dilute. So we will go ahead with the understanding that this is a dilute copper 2 solution. So these are the ions that we have. We have Cu2 positive ions, we have sulfate 2 negative ions, we have H positive, and we have OH negative. So in these kind of questions, what you need to understand is that the blue color of copper sulfate comes from the Cu2 positive ions. This is the understanding that you should always have. Especially in electrolysis, they do ask questions related to these time and again. So the blue color is maintained due to Cu2 positive. Why I am discussing this now, you will understand as we start doing this question. So let us look at the anode. Anode is the positive electrode. At anode, we will have a competition between the anions, so sulfate negative and OH negative. Now a basic understanding you can always have is that this doesn't get discharged. It is always the OH negative that gets discharged if a competition is between sulfate and OH negative. So And when OH negative, in any condition when OH negative gets discharged, this is the equation which is always followed. So this is a very important equation in electrolysis. You should plan this. So 4 OH negatives gives 2 H2O plus O2 gas is liberated, and 4 electrons are given. So at anode and oxidation is taking place, loss of electron is happening. So at anode oxidation is happening, and you will see that at anode oxygen gas is liberated. They might ask you the test, they might ask you the use of oxygen. So this is the anode part. At the cathode part, what will be happening is that we will have competition between Cu2 positive and H positive. So Cu2 positive will get discharged, Cu2 positive will get discharged, and Cu2 positive will get discharged. It will take 2 electrons and form Cu. But what is always recommended is that we have the while writing these half reactions, we have the balance of electrons. So though I could have written this equation as Cu2 positive plus 2 electron gives Cu, I could have written this, but I want to maintain a balance of the electrons. So the number of electrons which are being lost should be the number of electrons which are gained. So that is why I have multiplied this equation both sides by 2 just to maintain the balance of the electrons. So that is why I have written the equation like this, so that I can balance the electrons. So this is what will be happening at the negative terminal. Reduction is happening at the negative terminal. Okay. Now there are few things that we need to understand before we start looking at the question. See, this Cu2 positive, because this is getting discharged at the cathode, at the negative terminal. So you'll have a layer of Cu which will start depositing here. Now because this layer will start getting deposited here, and that is why I told you that blue color CuSO4, the blue color is due to Cu2 positive. Now as the concentration of Cu2 positive starts getting low, because the Cu is getting discharged and getting deposited here, the blue color of this solution will lighten. Blue color of solution will lighten, will start to fade away, The second thing that you need to understand is that because these electrodes are made of platinum, so there will be no difference in the size because they are inert electrodes. These are the questions which are being asked, so that is why I am discussing here. So the first question states whether the mass of the cathode increases, decreases. No, nothing happens to the cathode because platinum electrodes are used. So this is done. Change in appearance, if any of the electrolyte, when platinum electrodes are used. So platinum electrodes are being used, the blue color fades, as I have discussed before. What is seen at the anode when platinum electrodes are used? So at the anode positive terminal, oxygen gas is liberated. Write half equation for the reaction at the anode. We have written this, so this part of the question is over. Here we have taken aqueous copper sulfate solution and we have used the inert electrodes. Interesting part. In the next part, what he says is the electrolysis is repeated using copper electrode. So now what is happening is that we have a solution of copper. We have a solution of aqueous copper sulfate. We have a solution of copper sulfate, but instead of electrodes being inert electrode, now we are using the electrodes which would be active. So we will have a setup like this. Roughly, we will have a setup like this. I'm making a rough figure here. That we'll have these two would be copper electrodes. This would be the positive terminal, this would be the negative terminal. I'm not showing the cell. And we will have a electrolyte of aqueous copper sulfate. Now, what are the electrolytes from what are the ions we'll be having? We'll have ions like Cu2 positive, SO42 negative. These will be coming from copper sulfate. We will be having H positive and OH negative. This will be due to the aqueous part. We have active electrodes. So these active electrodes would be taking part. So now we can very well rest assured that it is only the Cu2 positive which will be getting oxidized and reduced. We don't even have to worry about sulfate or hydroxide or H positive. It's the Cu which has taken part of this electrolysis process. So these are the easiest. Whenever you see an active electrode will be doing all the dance. So at anode, this is the reaction which will be taking place. Positive terminal, here there will be a discharge of 2 electrons. So at the positive, you can assume it like this. Just for your understanding, you can look at it at like this. That 2 electrons would be pushed up and Cu2 positive will enter the solution. So this Cu2 positive will enter the solution and these 2 electrons will go up towards the positive end of the cell. So this is what is happening at the anode. At the cathode, the negative terminal, the right side that I've discussed again and again, that always maintain this consistency. The positive electrode, let it be towards the left side, and the negative electrode, let it be on the right side. This is the consistency that you can maintain, so that you don't get confused and you do all the questions like we have done to 10 to 15 electrolysis cases. So this will get hammered in your brain. So at the cathode side, again Cu2 positive will be taking part. The Cu2 positive now will gain 2 electrons from here and will get discharged as Cu. So this, you will see a layer of Cu here. You will see a reddish brown layer of Cu here. So this is actually called the purification of copper. This is used in the purification of copper, where we want to increase the concentration of copper. So we will have the impure copper on this side, and we will have pure copper on this side, and we will see that as the reaction goes on, this impure copper, this decreases in size. This will decrease in size because the movement of copper is taking from the left hand side towards the right hand side. But now the interesting thing is the Cu2 positive, due to the concentration of Cu2 positive is maintained. So the color of the solution won't change. This blue color will remain the same. It won't get affected like it got faded in the previous example where we had taken inert electrodes, but now the color will remain the same. And that is why they have asked questions like these. State whether the mass of the cathode increases, decreases, remains the same when copper electrodes are used. Of course, the mass of anode will decrease. Mass of cathode will increase. I've told you this anode would be the impure part. Describe the change in appearance of the electrode when copper electrodes are used. The electrolyte, the blue color will remain the same because the concentration of Cu2 remains the same. So this is an interesting question, and because it requires a lot of understanding in terms of you should be aware of the effect of the electrodes, whether they are active or inert. Let's look at the next question. Concentrated aqueous NaCl is electrolyzed using inert electrodes. So, as we have discussed earlier also, you need to carefully look at what kind of electrolyte it is. So, for example, in this case, it is a concentrated aqueous NaCl. So, what we need to understand by this is that the concentration of Na and Cl ions would be more. and because it is aqueous, so we'll have ions of hydrogen and OH also. So in the bucket, we will have these ions which will want to get which will rush towards the electrodes to get discharged. So these are the electrodes that we will be having. The second important thing that we need to understand is that we are using inert electrodes. Because we are using inert electrodes, so inert electrodes won't have sort of not much role to play. So the competition will be between H plus Na plus to get discharged, and the competition will be OH negative and Cl negative to get discharged. So these will rush towards the anode, and these two guys will rush towards the cathode to get discharged. So let us focus at the anode first. We understand that at anode there will be oxidation which is taking place. So anox at anode oxidation will be taking place. Oxidation is loss of electrons. Fine. At so when these uh, uh, in this setup, the anode is the positive side. It is always, we have discussed earlier, it is always the left side of the setup. So these negative cations will rush towards the anode side. Now that is why this word concentration plays a role here, because if this was a dilute NaCl solution, then OH negative would have get discharged. But now because it is a concentrated solution, concentrated aqueous NaCl is also called brine. This itself is another question. So always remember that concentrated aqueous solution is also called brine. You should know that. So the competition is between OH negative and Cl negative. We are discussing anode. Now, because the concentration of Cl negative ions is more, so in this case Cl will get discharged. So you will have a reaction like this at the anode, that 2Cl negative will get discharged and it will form chlorine gas. This will be given off and you will have 2 electrons. So these 2 electrons, we can understand it like this, that the 2 electrons are flowing from the electrodes upwards. And it makes sense also, like we have discussed earlier also, that the electron flow would be something like this. The negative, the anions will flow in the clockwise direction, and the cations will flow in the anti-clockwise direction. So they will flow in the like this. This would be the anti-clockwise would be the flow of the cations, and clockwise would be the flow of the anions. So Cl2 would be given off, and Cl2, remember, chlorine gas is green in color. At times they will also ask you the color of the gas. So the color of gas in this case is green. Then at the anode, at the cathode side, there is a competition between H positive and Na positive. Remember that though the concentration of Na is more, is hydrogen which is get discharged, hydrogen ion which gets discharged, hydrogen cation that get discharged, and H2 is liberated. At the cathode, remember that at the cathode, in concentrated aqueous NaCl electrolysis, the chlorine is discharged on the anode side, and hydrogen is discharged at the cathode side. When hydrogen is discharged, they usually ask you about the test of hydrogen. I'm talking about the theory questions also. So the test of hydrogen, as you very well know, is a pop sound. So these are the questions which are asked. So brine can be asked, question as a brine can be asked, the color of chlorine gas can be asked, test for hydrogen can be asked. So this is an important question. NaCl is an important question because there is another question which can be asked in terms of NaCl. This is another question which can be asked. Here they are asking about the dilute aqueous NaCl is electrolyzed using platinum electrodes. So remember, when we are using platinum electrodes are inert electrodes. So this is another question, the electrolysis of dilute aqueous NaCl that can be asked. Actually, I wanted to show you, because this is concentrated aqueous NaCl, I wanted to show you the textbook also. So let us spend some time looking at the textbook page also. So this is the electrolysis of brine that I'm talking about. So brine, as I've told you, the concentrated solution of NaCl. Uh, because the interesting thing is here it is mentioned. Brine might not sound very exciting, but from it we get chemicals needed for thousands of products we use every day. So it's an important uh, uh, industrial application. So this is how the setups looks like in reality. The same thing is happening. I won't be going into much of detail, but I just wanted to show you. Chlorine is given on one side and hydrogen is given on the other side. So this is our anode. This is the positive side, the negative side cathode. And so these are what are the products used? There is another product which is formed sodium hydroxide. Sodium hydroxide would also be formed because sodium would react with water to form sodium hydroxide. That part is also there. So these are the uses. What is chlorine used for? At times they will also ask you about the uses of chlorine. So that is why I am discussing it here. Hydrogen, they might ask you uses of hydrogen. This is another interesting question. NaH solution. This you should know this, that at least you should know at least two uses of these. Okay. So this is about the electrolysis of brine. Dilute aqueous NaCl is electrolyzed using platinum electrodes. So it's an aqueous solution of NaCl. It is dilute, and we are using platinum electrodes. So inert electrodes are there. As we have discussed previously, also there is another kind of electrolysis that we can do, that we discussed here. We can do concentrated aqueous NaCl using inert electrodes. So there we had found hydrogen and chlorine. Now let us look at what happens when we are dealing with dilute aqueous NaCl. So the first thing that we always do is that we try to understand that what are the ions in the bucket. Bucket implies that this. So these are the, so what kind of ions we will get here. So because it's a solution of NaCl, so of course we will have Na positive and Cl negative. And because hydrogen is there, water is there, so we will have H positive and OH negative. So these are the pairs which will be competing with each other to get discharged. Now we have discussed this again and again, that there are three factors that we need to understand when we are doing electrolysis. The first factor, let me show you the. So there are three factors that we always keep in mind when we are discussing electrolysis. The first is the relative position in the electrochemical series. The second is the concentration of ions. The third is the nature of electrodes. Let's go from about these factors one by one. Concentration of ions in this case is dilute. We have a dilute NaCl solution. Fine. Nature of electrodes. There are two types of electrodes. We have a inert electrode. We don't have a active electrode. Now, relative position of electrolysis, position in electrochemical series of the ions. I'll write it here. Relative position of ions in electrochemical series. So what this implies is, so for example, in this case that we are doing now, let me write it here. So in this case, we have competing ions are H positive, OH negative, Na positive, Cl negative. It's a dilute solution. Now, between H and Na, H is here, Na is here. Now, increasing ease of discharge at the cathode. So, H will get discharged easily before Na. So, H will get discharged easily and this will go to the cathode. And always remember, these are the few things that you should remember. That when H positive ions get discharged, always hydrogen is found. So this is the reaction which will be followed for the discharge of H positive. This is the equation which we will be using. 2H positive plus 2 electrons is equal to H2. So this reaction in this case, the H positive will be rushing towards the negative electrode, that would be cathode. So cathode, we will have H2 positive, which will be discharged. As I've discussed before, they might, in the theory question, they might also ask you that what is the test for hydrogen. They might also ask you the uses of hydrogen. These are the kind of questions which are asked. And now look at the, let us come to the, when there is a competition between OH negative and Cl negative. So here also, increasing ease of oxidation. So if we look at the competition, this is how the ease of discharge at anode takes place. So if we look carefully, we will see that between OH negative and Cl negative, the OH negative will get discharged easily rather than Cl negative. Now Cl negative, when it get OH negative when it discharge, again this is one of the important equation that you should just cram. The OH negative will always use this equation to get discharged. So it will be, you need to cram this. 4OH negative gives 2H2O plus O2 plus 4 oxygen. This is where oxygen is discharged. So you look carefully, this is a reaction which will be taking place at the anode. And this is the reaction which will be taking care at the cathode. So at oxygen, they might ask you, another in theory question, they might ask you the uses of oxygen, or they might ask you the test for the gas which is liberated. That is, they are asking you the test for oxygen. So these are the question in theory question that they usually ask for 1 or 2 marks. So these are the two reactions which will be happening at anode and cathode. And this is for the electrolysis of dilute NaCl. So if you see, at anode, we will have oxidation, and oxidation will follow this reaction. At cathode, we will have red cat, we will have reduction. And this is the reaction which will be followed. And we will have discharge of oxygen at the anode, and we'll have a discharge of hydrogen at the cathode. Just to compare this with what we had done earlier. So if I compare this dilute one with the concentrated one, if we compare, here we had hydrogen which was liberated at the cathode, and we had chlorine which was liberated at the anode. And of course, this was a case of concentrated NaCl using inert electrodes. So in this sheet, I've taken the 3 cases, the electrolysis of dilute NaCl. I'm comparing it with electrolysis of concentrated aqueous NaCl, and I'm comparing that with molten NaCl. So that, we don't have any confusion when we look at all these 3 cases on one sheet only. Of course, the inert electrodes are there. Because see, the guiding principle remains that, in electrolysis, we understand that there are 3 main things which will be affecting us. The first thing will be the relative position of ions in the electrochemical series. So, for example, when I am comparing cations, so let us say I am comparing Na positive, the discharge of Na positive with the discharge of H positive, or discharge of H positive compared with Cu2 positive. So, which cation will get discharged at the cathode? So that will depend upon the, the increasing ease of reduction. So similarly, when I'm looking at the anions, again in anions when they rush towards anode, which one will get discharged first? Well, when let us say sulfate is competing with the hydroxide, so does sulfate gets discharged or hydroxide gets discharged? So this is one of the principles that we need to follow. Uh, one of the conditions which will be there, which will help us decide which ions gets discharged. The second is the concentration of ions. The third is the nature of electrodes. The case that we are discussing, we are dealing with inert electrode. Inert electrode. The concentration of ions we have in our cases, we have dilute also, we have concentrated also. So that is why it will be a good comparison. So let's see. So when I take dilute NaCl, these are the four competing ions. So basically Na positive will be competing with H positive, Cl negative will be competing with OH negative. Now between Na positive and H positive, if I look at this, between Na positive and H positive, of course H positive will get discharged first. So H positive gets discharged, and this is the reaction which takes place at the cathode. This reduction reaction takes place at the cathode, and when Cl negative, in terms of anions, the Cl negative is competing with OH negative. So OH negative is here, Cl negative is here. We are dealing with dilute NaCl. So OH negative will get discharged first. This will get discharged at anode, and consequently, this is the reaction which will be formed. This is the reaction that you need to cram. 4OH negative, very important reaction. Asked in MCQs also. No oxygen will be formed. So when I have dilute NaCl, you can try to understand it or you can cram it. Understanding is actually easier if you spend some time, you will be able to understand this. So when dilute NaCl is there, at cathode, hydrogen is discharged, and at anode, the oxygen gas is discharged. So this is about dilute NaCl. When I have concentrated NaCl, then again I have the, if I compare dilute NaCl with concentrated NaCl, the ions are the same. But what happens is the concentration of Na positive and Cl negative would be more. Now, how that affects is when Cl negative and OH negative, so there is a competition between Cl negative and OH negative. Because the concentration of Cl negative is more, so Cl2 would be discharged. Oxygen gas would be discharged at the anode. But the interesting thing is that between sodium positive and H positive, see the H positive gets discharged. This is the equation which is followed. One thing that you need to understand is that the number of electrons should be the same at cathode also, at anode also. So that you need to balance. So for example, in dilute NaCl, what we see is 4 electrons here and 4 electrons here. The number of electrons are the same. So please try to balance these. But in concentrated NaCl, here I have 2 electrons and I have 2 electrons here. So coming back to the competition between Na positive and H positive, though the concentration of Na positive is more, still H positive gets discharged. The simple reason is that, let us say that Na positive gets discharged. So Na positive will form Na, sodium metal. The sodium metal is so reactive that the sodium metal reacts with water again. Water is there in the solution. Sodium plus water forms sodium hydroxide plus hydrogen gas. So the sodium hydroxide again breaks down into Na positive and OH negative. So in the solution again, you have OH negative. And so that is the reason that, because see, try to understand that sodium is very, very reactive. So even if you, for less than a second it is formed, it forms Na positive and OH negative again. So the reaction that we will get is between Na positive and H positive, we will get hydrogen again, and this will discharge at the cathode. Now, if we compare between these two, hydrogen both are formed at cathode, but in the first case, oxygen is given out. Second case, Cl2 is given out. But in molten NaCl, there is, see, remember that in molten NaCl, the aqueous part is not present. So H positive and OH negative ions won't be there. We only have Na and Cl ions, and they get discharged as Na and Cl2 because there is nothing else. So this is the comparison that I wanted to make, so that you can clearly see that in these three cases between dilute NaCl, concentrated NaCl, molten NaCl, gases are discharged. Another thing that you need to understand is that if it in the theory question they will ask you about the reaction, they will also ask you the tests of the gases. They will ask you the test of hydrogen, they will ask you the test of oxygen, or they'll ask you the test for chlorine. How will you recognize chlorine is a green color? They might also ask you the color of the gas. So, for example, chlorine is distinctive green color. They might ask you the uses, they might ask you the use of hydrogen, of the use of oxygen, of chlorine. So, I wanted to capture these three reactions on one sheet, and in the next question, we have concentrated aqueous copper 2 chloride is electrolyzed using carbon electrodes. So what is the information we will get from here? So it's a concentrated aqueous copper 2 chloride electrolyte. So we'll have Cu2 positive, Cl negative coming from copper 2 chloride. Because it is aqueous, so we will have H positive and OH negative. So these are the four ions we'll be having. It's a concentrated solution. So the concentration of Cu2 positive and the Cl negative would be more. We are using carbon electrodes, so this would be carbon electrodes are inert electrodes, so they won't be taking part. They'll be just passing electricity. So we'll be looking at this in detail. Now let's look at the anode side. At anode, oxidation will be taking place. It's a positive electrode, so we will have these two anions which will be rushing towards this side, the positive electrode. Now between Cl negative and OH negative, because concentration of Cl negative is more, it's a concentrated solution. So Cl negative will get discharged, and the reaction you will have is 2Cl negative Cl2 plus 2 electron. So this will be the green colored gas that you will see on the anode side. Color of the gas which is discharged, uses of the gas which are discharged, test of the gas which are discharged. These are the common questions that you are usually asked. So we have looked at the positive electrode. Now let us look at the negative electrode. On the negative electrode side, that is at the cathode side, we will have reduction taking place. We will have two ions which will be rushing towards this side. Yeah, we will have two ions which are rushing towards the negative side. We have Cu2 positive and we have H positive. See, though concentration of Cu2 positive is more, but we also, if we look at the increasing ease of reduction, so Cu2 positive has far more hunger to get discharged than H positive between these two. So Cu2 positive will get discharged rather than H positive. So Cu2 positive concentration is more, also it has more hunger to get discharged. So Cu2 positive will get discharged as we will have a reaction like Cu2 positive plus 2 electron gives Cu. Now this Cu, so what we will have is that Cu, this is the reaction which is taking place at the cathode. So we will have a covering of Cu on this side. We will have a covering of Cu on this side. And there will be a discharge of chlorine gas on the positive terminal. So the answer to the question will be that at the negative electrode, we will have copper, which I have mentioned here. And on the positive electrode, I will have chlorine, green color gas, poisonous gas on the positive electrode. So let's move to the next question. Dilute sulfuric acid is electrolyzed using inert electrodes. We are using inert electrodes. It's dilute sulfuric acid. See, remember, before we start analyzing, I'm taking a longer route. I'm not considering this to be a MCQ. I'm also discussing the theory behind it. So whenever these questions are there, you should have a look at whether it's an inert electrode or it would be an active electrode. You should analyze uh, the ions which will be there. So if it is a dilute sulfuric acid, you will have H plus SO4 2 negative. Uh, if you want, you can also write it as 2H plus and SO sulfate 2 negative ions. Then water will break as H plus and OH negative. So these are the four ions that we have. Once we have seen these four ions, we understand that at the negative terminal, that is at the cathode, there will be a competition between the, usually there is a competition between the positive ions. But here there is actually no competition because H plus is only there. So of course we understand that once when H plus gets discharged, it gets discharged by taking two electrons and hydrogen gas is evolved. And this gas is evolved at the cathode. Red cat reduction takes place at cathode. Reduction is gain of electrons. So these two electrons are gained by the H plus cation and hydrogen gas gets liberated. So this is the reaction that we have at the cathode. And now if we look at the reaction which is taking place at the anode, now at anode there is a competition which is taking place between sulfate and hydroxide ions. This would be the positive terminal. This would be the anode. Anode oxidation will be taking place. Oxidation is a loss of electrons. So the competition will be between hydroxide and sulfate to negative to lose the electrons. And we understand that whenever there is a competition between sulfate and hydroxide, the hydroxide gets discharged. Whenever hydroxide gets discharged, this is the reaction you always should remember. I've suggested many times in this lecture also that please do cram this reaction. Another thing that you need to understand is that the electrons, when you are writing the ionic equations, half reactions, please balance the electrons on both sides. So, for example, here I am writing the discharge of hydroxide like this. 4 electrons are liberated. So, on the cathode side, these 4 electrons should get accepted by 4H plus and 2H2 should be found. So, this would be the correct way of writing the half reactions. So, and we have discussed many times before, this is the positive terminal, this is the negative terminal. And we have also discussed in theory question, they will ask you uses of hydrogen and oxygen. They will ask you the test of hydrogen and oxygen. At times when chlorine is liberated, they also ask the color of the. So these kind of supplementary questions are also there. And we have covered a lot of these questions in this long lecture. So this is a reaction we have. Positive electrode, hydrogen gets liberated, and negative electrode, the oxygen gets liberated. Of course, because this is MCQ, so they have shown 2 electrons here, and they have shown 4 electrons here. Best practice is whenever you are, if you are attempting a theory-based questions, the best practice is to balance the number of electrons which are being either given out or being accepted. So let's move on to the next question. So let's move to the next question. Molten potassium chloride is electrolyzed using inert electrode. So this is actually the simplest of the question for 2 reasons. One is the electrodes are inert, so the electrodes are not taking place. It's a molten potassium chloride. So in molten potassium chloride only we will have 2 entities, K plus and Cl negative. So at one part, at the anode, I'll write it here. So at anode, oxidation will be taking place. Oxidation is loss of electron. And at cathode, Anode is a positive terminal. Cathode is a negative terminal. At cathode, reduction is taking place. Reduction is gain in electrons. So this is what will be happening only between K plus and Cl negative. And remember, whenever Cl negative gets discharged, you'll have chlorine gas. Chlorine gas is green in color. It's poisonous in nature. So these are the few things that usually they ask when they are asking about chlorine. So at anode, oxidation will be happening. Oxidation is loss of electrons. So here you have loss of electrons here. And this is the reaction which will be taking place. Chlorine gas would be liberated. And at the cathode, the 2 potassium will accept 2 electrons to form 2K because I want to balance the electrons. And if you see the experimental setup, this is how the experimental setup would look like. There will be a positive terminal, negative terminal. The positive terminal, this would be the electrode which will be called anode. This is a negative terminal. This is a negative terminal called cathode. And here we will have the molten K positive and Cl negative ions. So this is a fairly simple question. This is the easiest of the electrolysis question. So let's look at the next questions. See, now what I have done is I have taken different kind of questions which involve the hydrogen oxygen fuel cell. So this is a topic which is there, hydrogen oxygen fuel cells. And a lot of times these questions are being asked, these kind of questions are being asked. So in almost every question paper that I have seen, the hydrogen oxygen fuel cell, one question is asked. So I'll just brief you. So what we are during electrolysis, usually what we do is that we pass electrical energy, and using the electrical energy, we uh, convert electrical energy into chemical energy. But in the hydrogen oxygen fuel cell, there's a different thing which is happening. We are using chemical energy to produce electrical energy. So basically, this is the reverse of the process of the what we are doing in electrolysis. One thing that you need to understand is that in hydrogen oxygen fuel cells, the chemical energy is getting converted into electrical energy. This is the basic thing that you need to understand. And so this is what is called a fuel cell. This is a reaction which takes place. So H2 plus O2 gives H2 plus this energy. We get energy from this reaction. So this is the setup which is shown in your textbook. So hydrogen is pumped in from tank, oxygen from here. They have actually shown the example of hydrogen fuel based car. So hydrogen is pumped in from tank, oxygen from air is done, and the electrical energy drives the car. So let us look at the questions which have been asked in recent papers. So which equation represents the overall reaction in hydrogen oxygen fuel cell? Of course, this is the reaction which takes place. So this is the first question taken from 2025 paper. There are three more questions. Hydrogen oxygen fuel cells can be used to power vehicles. Which statement of hydrogen oxygen fuel cells is correct? So this is wrong. Again, this is wrong. Hydrogen used is a fossil fuel. Again, this is wrong. The correct answer would be chemical energy in the fuel is converted to electrical energy. So chemical energy, which is there in the fuel, that is being converted into electrical energy. Two statements about hydrogen are listed. Hydrogen is used as a fuel, of course. When hydrogen burns in air to form water, thermal energy is produced. So both the statements are correct. And of course, statement 2 explains statement 1, that why is hydrogen being used as a fuel. Because when hydrogen burns in air to form water, thermal energy is used. So statement 2 is basically explaining statement 1. Statement 1 is hydrogen is used as a fuel, and statement 2 explains it. Uh, Next question. Which statement about hydrogen oxygen fuel cells are correct? They convert chemical energy into electrical energy. Of course, chemical into electrical energy. They do not produce any atmospheric pollutants. Yes, it is correct. Because the only thing that we get is water and energy. Hydrogen is reduced in the fuel cells. So I will explain this. So this is the reaction which is taking place. Here the oxidation number of hydrogen is 0. But if we see here in water, that you remember when you are doing these kind of questions is that what I suggest my students always is that always take the left hand part as anode and don't change that. So this is your cell. This is your cell. This is the positive part. This is the negative part of a cell. So just keep it like this. Always keep the anode on the left side of the paper and the cathode to be the right side of the paper. So what is, and another thing which I suggest is that so the mnemonic that you can use is red cat. The red cat. Red cat implies okay. Red cat implies that the reduction will always take place at the cathode. Another thing that you can another phrase that you can remember is an ox. An ox. So what does an ox implies? An ox implies that the oxidation will always take place at the anode. So this is a mnemonic that you can remember. An ox. Red cat. So reduction will always take place at the cathode, and at the anode always oxidation will take place. And we already know the mnemonic for oxidation and reduction also. It is oil rig. this is the this is the mnemonic that I prefer. So oxidation is loss of electrons. Reduction is gain of electrons. So the two mnemonics that we'll be using is an ox and an ox red cat oil rig. So keep the anode, the positive side of the cell, always on the left hand side of the paper and the cathode on the right side of the paper. Then see, these are called the electrodes. These are called the electrodes. The solution which will be there, this is called the electrolyte. We'll be taking different kind of conditions. Another thing that you can remember is that the positive ions, they'll be moving like this. They will always be moving in the anti-clockwise direction, and the electrons will be moving in the clockwise direction. One way of remembering this can be that you can assume that electrons are coming like this. They are coming like this from the right hand side. They are going down like this, and the positive ions, they are going like this. These are simple ways of visualizing electrolysis. They will help you a lot because at times things get a bit confusing. So always remember that the positive ions will move in the anti-clockwise direction. If we complete the cycle, they will be moving in the anti-clockwise direction, and the negative ions, they'll be moving in the clockwise direction. Remember that. The third and the final thing that you need to understand is that in electrolysis there is a selective discharge of ions. So what does it mean, selective discharge of ions? So you will have you will have ions, you will have cations and anions. You will have cations and anions, and if you have done electrolysis, you will understand these cations and anions have to there has to be a discharge of the cations and the anions. So what I'm trying to say is that there's a selective discharge of ions. The selective discharge of ions depends upon the nature of electrodes. Nature of electrode implies that sorry. See, there can be conditions where you are dealing with inert electrodes. Inert electrodes implies that they won't take part in the electrolysis. So they will be electrodes like graphite and platinum usually. So these are the inert electrodes. They don't take part in the discharge. But that is not the only case. You can have active electrodes also. Now these are the electrodes which will actively take part in the electrolysis. So they will have there will be conditions when the one of the both the electrodes would be copper, nickel, silver. So these are the kind of active electrodes that you will see. So the first condition is that there is a selective discharge of ions. It depends upon, first you have to see what is the nature of electrodes that you are dealing with. Second very important thing is the concentration of ions. So for example, I'll give you, or you might be knowing, or I'll give you a small example. For example, for sodium chloride, you can have three conditions. You can have molten NaCl. You can have dilute NaCl. You can have concentrated NaCl. Now, in these are three type of electrolysis that are possible with a single compound. So the kind of discharge which will take place at the electrode would be different. So that is why I'm saying. So the second condition that you will have to see whenever you are doing a question is you will have to see the concentration of the ions. The what kind of electrolyte is there. We'll see the examples. You will understand. But here I'm just giving you a brief before I start the main lecture. The third thing would be relative position in electrochemical series. So what this implies is that you will have as electrolyte in the electrolyte, you will have positive ions, you will have negative ions. So there will be a competition to get discharged. So for example, in sorry, so in anions, which one will get discharged? In cations, which one will get discharged? So that also depends upon the relative position in the electrochemical series. So what this implies is, so for example, you have cations. Now cations, all these metals that you see on the side, they will form cations. So for example, you might have something like Na positive, or you might have something like Cu2 positive. So as you can make out that these cations, they will get attracted to the cathode, that is the negative end of the electrode. So when they are going to discharge, which one will get preference? We'll see examples. So when we have to see which one will get preference, so we need to understand that it depends upon the increasing ease of reduction. So for example, let me take an example. So for example, we have H positive and we have Cu2 positive. So in this, Cu2 positive will be more, no, will want to get discharged more. There will be an increasing ease of discharge at cathode by gaining electrons. So Cu2 positive would prefer to get two electrons and get discharged at the cathode rather than H positive. So what I'm trying to say here is that it depends upon the discharge of the cations depends upon this series. Then if you see in electrolysis, you will get anions like these. So when you have anions like these, so which will get discharged preferably. So for example, let us say there is a competition between sulfate ion and hydroxide ion. So which will get preference to get discharged easily. Now these, as you can understand, these anions, they will be attracted to the positive electrode. That is, they will be attracted to the anode, the left electrode, and they would like to lose the electrons. For example, between sulfate and hydroxide ion, the hydroxide ion will always want to get discharged easily. And one of the equation that you need to remember is that when hydroxide is discharged, O2 is formed, and this is the equation that you need to remember. So I'll repeat. Whenever hydroxide is discharged, oxygen is formed. So hydroxide will get attracted to the positive end. Positive end is anode. At anode there will be a loss of electrons because at anode we have said anox. So at anode oxidation will take place. Oxidation is loss of electrons. When there is a loss of electron, this equation will always be there. So hydroxide will always get discharged using this equation. And remember, whenever hydroxide will get discharged, oxygen will be formed. And if you see hydrogen getting discharged, then hydrogen would be. So the brief is that there are few things in electrolysis that you need to remember before you start attempting the question. So, and when you are doing electrolysis, that selective discharge of ions is selective discharge of ions. Principle of selective discharge of ions is now. After this brief, I'll start with the questions one by one. We'll be going through the questions, and the oxidation number of hydrogen is +1. So basically, hydrogen, if you look carefully, is getting oxidized because oxygen goes from 0 to -2. So oxygen is getting reduced, and that is why, and hydrogen is getting oxidized. That is why this is incorrect. And 1 and 3 only would be the correct answer. So these are the questions which I saw in 2025 papers, which were asked from hydrogen oxygen fuel cells.